Tonight for Science Thursdays, I'm going to talk about dark matter. It's kind of amazing stuff. When you look out the window, everything you can see only takes up about 4 or 5% of the known universe.
Wait, seriously?
Yeah, seriously. People, plants, planets, stars, galaxies, everything that you can see, everything that can be seen, is only 4 or 5% of the known universe. And we can tell this because the way the galaxies spin, there's just not enough stuff that we can see to account for how fast they spin.
Sounds like someone flubbed a number.
If I understand right, that's kind of one of the theories behind the problem of dark matter. It's not so much that they added it up wrong, it's more that we don't know enough about how the universe works to say, hey, this is definitely how this everything is. And as far as we know, there may be some gaps in the theories of general relativity. But as far as we know, galaxies and galaxy clusters just wouldn't work without the extra matter of the dark matter, because of how they spin and how fast they spin, with the way that we understand how matter works. If there wasn't the extra gravity of dark matter, everything would just flown straight apart, and along with all of the gas and all of the stars that would have just blown way apart. So planets and solar systems as we know them just wouldn't exist as far as we understand physics.
So, instead of reworking the things they know, they just invent a special matter that fixed the problem.
It's awfully kind of funny to have you point that out, but as far as we know, dark matter doesn't reflect or absorb or interact with light in any way. So it can't be made out of electrons, protons, or neutrons, because those all interact with light, and those attract themselves. And that's what builds up matter. Since dark matter is something different, it can't be made out of regular matter.
So what is this stuff made out of?
A bunch of WIMPs. WIMPs in astronomy is weakly interactive massive particles. And WIMPs are subject for another video, an interesting subject in themselves. But they're the leading thought of what dark matter is. There's a couple other things that could be dark matter, but probably aren't. We'll start with black holes. There's quite a few reasons it's probably not black holes. Going into physics, I don't completely understand myself, and a whole bunch of other reasons it's probably not black holes. Black holes do a lot of stuff. That would probably mess up a whole lot of stuff if there was that many black holes. Next up would be the machos. Yeah, astronomers, more than other scientists, which is saying impressive stuff, really love their acronyms. Well, with astronomy, it's either an acronym or a long string of letters and numbers. But anyway, machos are massive, compact halo objects.
Wait, what? Halo?
Not that halo. The halo objects would be a whole bunch of objects floating around a galaxy that's made up of failed stars, massive planets, black holes, which again leads into problems I can't really comprehend myself. But the problem with that many compact halo objects would be you'd probably see something. If there was that much stuff floating around outside of the galaxies, even though they're not glowing themselves like stars are, you would think they'd block something out. But that's one of the theories that they have. Probably not dark matter though. Next up are the brown dwarf stars.
That sounds racist.
If you think that sounds bad, wait till I start talking about the black dwarf stars. But anyway, brown dwarf star is like a think Jupiter, the massive gas planet floating off in itself, just a whole lot more massive. I think they'd have to be, I don't quote me on this because I forgot to write it down. I think it has to be like 15 to 20 times bigger than Jupiter, which is saying a lot about Jupiter in itself. But they're not quite big enough to become stars, but there are pretty sizable objects. Unfortunately, if there are that many that sized stuff floating around the galaxies, you'd think you would see something. I know we haven't quite started looking. I mean, relatively speaking, we haven't really looked a whole lot in the galaxy, but you'd think we'd see something floating around, especially if there's, especially since we can only see 4 or 5% of what's out there. If there was that much stuff floating around, you'd think you'd be able to see it. Next up is the neutrinos, which, wow, those are some weird stuff.
Let me guess. That's another video.
Neutrinos could be a whole series of videos. Neutrinos are one of the 3 building blocks of regular atoms. There's electrons, which are negatively charged, protons, which are positively charged, and neutrons, which are negatively charged, very creatively named. But, and since they have no charge at all, they're not attracted to the electrons or the protons. So, if there is massive clouds of neutrons floating around, it wouldn't interact with regular matter. It's said that a single neutron particle floating through space can go through an entire light year of lead without noticing. So it's only interacting with the protons in an atom through the gravitational force of the proton, which again, it's a single single hydrogen atom, but the protons in atom, not a whole lot of gravity. So it could be that there are just massive massive clouds of neutrons floating around. So it does fall into the group of doesn't interact with regular matter.
So is that it? Question answered.
But I don't have a definite reason why it couldn't be dark matter. It just, when I was looking up stuff, it said it's probably not. If it was something that easy, or relatively easy, because we're talking about quantum mechanics, I don't think if that was the answer to the question, I don't think we'd still have the question. So it couldn't just be, hey, it's neutrinos. And I've tried looking into more of how neutrinos work, but we start looking into quantum mechanics, and once quantum mechanics comes up, I just feel like brains oozing out my ears. I think I like to think I'm a pretty smart guy, but when it comes to quantum mechanics, you're on your own. And another particle when it comes to quantum mechanics is called the axion. There's some quirks with the strong nuclear force that I don't completely understand because, again, quantum mechanics. And there's the axion is a hypothetical particle that can explain some of these quirks. But unfortunately, when I get too far into the Wikipedia pages on this stuff, where I'm getting most of my information on this video, I'm pretty sure it's written in Elvish. I can't read it. Really? On this channel? Really? But anyway, what scientists have discovered is the way that galaxies are floating out in space, there has to be giant webs of dark matter just floating, just stretched out through the universe.
You said dark matter doesn't interact with regular matter.
Well, it doesn't directly interact with matter. It's just the massive amounts of gravity in the areas in the filaments of the web of dark matter. It just everything just falls into the great web of dark matter that's stretched through the universe. And one of the kind of great things that dark matter lends to is gravitational lensing, where there's a galaxy there, but the light behind the galaxy gets warped by the galaxy in front of it, so it'll focus the light, so we can see, in essence, we can see farther in space than we normally would be able to.
Let me guess, that's another video.
And quite a few videos could be made out of a lot of subjects that brought up in this video. But this video is getting longer than probably anybody wants to watch. So follow me every second Thursday of the month where I talk about a science topic. I want to get more practice in this. But anyway, yeah, that's dark matter. Screw you. My video. I swear. October is supposed to be a horror month, but I couldn't think of anything to say. Anyway, that's video. Please like, favorite, subscribe. Comments are appreciated, and that'll do it for tonight. Thank you.